Applications with logs. An earthquake has intensity x, then its magnitude as computed on the Richter scale is this function right here, where I0 is the intensity of a small measurable earthquake, but we're going to let it be equal to 1 for this problem. So there's a question. The 1994 Northridge earthquake had a magnitude of 6.7 on the Richter scale. That's the R of x. That's the magnitude. And the 1964 Alaska earthquake had a magnitude of 9.2 on the Richter scale. How many times more intense to the nearest whole number was the Alaska earthquake than the Northridge quake? Okay, here's the Northridge. It was a 6.7 in Northridge. And the Alaska was 9.2. So let's see what we have here. Considering the Northridge earthquake, R of x gives you the magnitude, and x is the intensity. That's what we're trying to find. So for the Northridge quake, the magnitude was 6.7. We're trying to find the x intensity. I0 equals 1 was given. So the Richter scale magnitude is log of the intensity over that 1. So x over 1 is just x. So we plug in the magnitude as 6.7 and we get our equation. Now we got to solve this equation. So method 1 is to rewrite as an exponential equation. So if log base 10 of x is 6.7, that means the exponent you put on a 10 to get x is 6.7. So 10 to the 6.7 equals x. So x is 10 to the 6.7. That's the intensity. That's about 5 million and so forth. Method 2 requires less thinking, which might come in handy. So I actually like method 2 a little bit better. But the original belief of it takes a little bit of thinking. So you have 6.7 is log x. That's what we had here. So 10 to that equals 10 to the right side. See, these two are equal. So 10 to something that's equal to something else, 10 to that has to be equal. Okay, so it's just like raising it to equal things. So what does that mean? How do we figure out this part over here? Well, another way to say that is putting 10 as a base on both sides. That's the way to say it. Put 10 as a base on both sides. Okay, so now how are we going to deal with this 10 to log base 10 of x? So on the right side, which is here, 10, that's the 10, is being raised to the exponent, logs are exponents, that we raised 10 to in order to get x. 10 is being raised to the exponent that we have to put on a 10 to get x. But that exponent's on a 10. So we get x. So this side here is x. Another way to think of it is that an exponent 10 to an exponent undoes the same base. If this is log 10 and it's 10 to the log 10, it undoes it and just gets you back to x. Okay, now if you believe that, then you can just go ahead and anytime you have a equation like this, you can put 10 as a base on both sides and go from there. Okay, so 10 equals x equals 10 to the 6.7 again. So that's the intensity. You use one of these two methods, one or the other. You don't have to use both. Okay, so for the Alaska, the magnitude was 9.2, and we're trying to find the x intensity. So the magnitude was 9.2, the I0 was 1, so log of x is 9.2. I'm using method 2. I put 10 as a base on both sides of the equation. So if these two numbers are equal, 10 of those numbers ought to be equal. 10 to the log x undoes the log and just gives me back to x. You're not really canceling. I don't like to see canceling that. I like to see just the understanding that it's the inverse operation is what it really is. Okay, and then I just turned it around, and x is 10 to the 9.2 intensity. That's about 1,584,000,000 something. So the question is, how much more intense was Alaska than Northridge? So I'm going to divide Alaska intensity divided by Northridge intensity. Alaska divided by Northridge. 10 to the 9.2 divided by 10 to 6.7. When you have the same base, you subtract the exponents. Subtracting the exponents, I get 10 to the 2.5, and it's calculator time. That's about 316 to a whole number. So Alaska over Northridge is 316. You multiply the Northridge over, Alaska equals 316 times Northridge. That's why we divided it in the first place. That means that the Alaska earthquake was 316 times more intense than the Northridge earthquake. When you think about it, that's really intense. The Northridge earthquake caused a lot of damage all around the Northridge area and beyond. And the Alaska earthquake in 1964 was 316 times more intense.